Hello, this is the attention and Stroop task presentation made for our cognitive psychology final project by Aspin, Denson, Marfa, Glazyrina, and Aroog, Khaliq. We hope you enjoy it. To understand attention, first we need to understand what cognition is. And so cognition is really just our way of processing information and thinking. And cognition within psychology is the source of a ton of processes that we use all the time, things like attention, perception, memory, problem solving, learning, and language. So most brain related processes that we end up using on a daily basis to make decisions or to learn things or talk to other people or even retain focus during class and lectures are all related to cognition. So now let's talk about what attention is. So attention is something that we can think of in two different ways. It can be a mental resource or a mental process. So if we think of attention as a mental resource, we can kind of picture it as a fuel that powers our cognition. And so just think about how cars work. If you have fuel, you can move your car around, and if you don't have fuel, you can't really drive. So you have to go back and refill. So that idea essentially is that if we're thinking of attention as a mental resource, it's limited and we kind of have to control it. So we'll talk later about what controlled attention is. But if we think about it in a different sense of attention as a mental process, in that case, you're using your attention to concentrate on a problem. And because it's just something that you're putting towards the problem, it's kind of an unlimited situation of you're just redirecting this source. And that can be thought of as automatic or input attention, which we will also discuss later.
As mentioned previously, there are two types of attention processing. The first one is controlled, which requires more resources and occurs more slowly because you're controlling your attention, you're pointing your attention towards something while aware, so it occurs with awareness. The next one is automatic, as denoted by the name itself. It requires less resources because it's occurring automatically or without awareness, and as you can imagine, this occurs more quickly as well. Both of these are utilized in the Stroop task, which will be demonstrated later.
So to tie all of these ideas together, we're going to actually try the Stroop task. And if you want to follow along at home, here are the rules. Make sure that you're not reading the words that come across on the screen. Your goal is to try and name the colors that you see. And have someone else, or you can also do it yourself, record the time between each version of the Stroop test and then see how you differ from phase to phase.
Red, green, black, red, blue, pink, yellow, blue, green, red, green, orange, yellow, blue, pink, black, black, orange, red, green, orange, red, blue, yellow. And that completes the phase. Red, green, black, red, blue, pink, yellow, blue, green, red, green, orange, yellow, blue, pink, black, black, orange, red, green, orange, red, blue, yellow. That completes the second phase. Yellow, black, pink, black, black, yellow, orange, green, blue, yellow, pink, red, black, red, green, blue, red, orange, yellow, orange. And that completes phase.
All right, I know what you're thinking. What's the point of all this? Well, there's actually a pretty big point to this. Well, when Aspin was doing this entire test, he scored for phase 1 8.56 seconds, which is pretty fast. And that would make sense because it's congruent. The color and the word match. For phase 2, he scored 12.83 seconds, a little bit slower. And that would also make sense because when he reads the word and he sees the color, it's not like interfering with one another, but it's not really helping it either. So that would make sense. And then for phase 3, he got 17.73 seconds, which is a lot slower than the other two, which makes sense because it's incongruent. The color does not match the word. So when he reads the word and he sees the color, it conflicts in his mind, so he has to like process it a little bit longer. And so what's really happening is facilitation and interference. Facilitation is when the automatic processes of reading the name actually makes the naming of the color go faster, and interference is when the automatic process of reading the name actually slows down how long it takes to name the color. So for phase 1, obviously it would go faster than phase 3.
Okay, now we're going to move on to the traditional results and analysis portion of the presentation. The reason we're presenting this now is to help complement what Marfa was talking about, and we're going to try to present it in a different way, a more applicable manner. So for example, we have a graph present. The y-axis is going to demonstrate the distance of the diameter in millimeters, and then you move on to the x-axis, which is time in milliseconds of the Stroop task itself. We have 3 different categories present, as you can see by the 3 lines. We have the blue, which is congruent, we have the red, which is incongruent, and we have the dotted green line or the dashed green line, which is non-color words, or the baseline. And as you can see from the baseline, it's in between both the incongruent, which is above, and the congruent, which is below it. And this makes sense, as Marfa said, because the congruent is going to be the same color as the word itself. So it's going to be, for example, red will be in the red ink, which will be easier. And as she said, it'll facilitate the mind to be able to read it quicker. And incongruent's not going to match it at all. It's actually going to demonstrate the phenomenon of interference, which will make it harder to read.
Thank you for tuning into our presentation. We hope you learned something about cognition, attention, and the Stroop task. And we would like to apologize to everyone out there who is red-green colorblind, because this will be a lot harder for you to do. Thank you.
Bye.
Bye.